Okay, let's have a look what we've now got in version 410.98. Now this release is mainly looking at the user being able to change the outlet connections for the fan and for an Ivase. So I've put in a duty here and I've also set an area, a required area, because this is mainly why you'd use this feature. So let's have a look and just do a survey of some of the designs here. And we can see that some need a reducer or a change of section increasing the outlet velocity, and some of the others need an Ivase or a diffuser. So let's have a look at one of these. So I'll just pick this one, say, double click that, so we can see that it selections on the curve. Let's go next, and we've got a lot more information here now that comes up with the casing material. So we can change both the outlet depth and the width of the casing, and we can also take a quick look at this stage of proceedings now, which we couldn't do before, to look at the casing. So that's how it looks. So we've got this contraction across the depth and across the width. Now if we wanted to simplify that, you'll notice that in this particular portion here, it's telling us that we can just change the depth to 934 millimeters to meet this criteria of this specified area. So let's try doing that. So I'll change that to 934 and say apply. So now we can see that this is telling us that the separate Ivase is not required. And we've also actually increased the pressure. We've reduced the losses, in other words, through this outlet. So let's have a look at that. Okay, so that's now very simple, and we could use that as an alternative provided we don't have to meet a specification of size from the customer, supplied by the customer. So we've got inside flange information shown there. The thickness of the Ivase is now not relevant because we're not going to use one. So let's just go back to the curve, and we can now see that we've increased the flow. Now we might not want to show an improved pressure. So under the options, we can just click this one here. Do not plot changes due to casing or Ivase modifications. So we just check that, and we're back on the duty point. So just doing that again, you can see that move easily. So let's leave that off for this demonstration. So let's go next again. Now things to note, you should really note this. Centrix does not reselect due to these changes, and we really need to be careful of changing the width in particular more than about 10%. So if we leave the mouse over the width, we've got the suggested limits of 361 to 529. So if I was to change that, we would be, let's change that to say 450 and say apply. And now we'll need an Ivase again, because we don't meet the required area. In fact, let's just have a look and see what that shows us. Okay, so now we've got this little contraction, but it's telling us that if we change the depth to 1000, say apply, and now we know there's no need for that reducer or Ivase. So we're back to there with slightly different dimensions. You can take dimensions from here. That's just inside that angle. Now if we were to select a silencer at this point, let's go next and select a silencer, a rectangular silencer, and let's do a calculation. Ideally we'd want to fix both these dimensions because we don't want to change that outlet area. So let's see what this gives us. Well, the first thing it tells us that it can't resolve a design. Might be because of the limit in the gap velocity there. So let's use calculate here, and this will do calculations not being restricted by this gap velocity. So we can see here that there are some here that we could use that are just over this specified velocity here. We could do a sort and find lower velocities and scroll down, but until we get to 24.9 we don't meet this noise level desired. Now presumably this is going to be a ducted outlet, so we may want to try using a higher level there, because we know that noise may only be breaking out through the outlet ducting that's connected to this silencer. So we might want to say, let's say 90, let's do a recalculation. And we've still got this high gap velocity. Alright, well let's accept that. Save the selection. And again, we don't have to proceed to the very end to be able to see how this silencer looks. And it looks quite reasonable. Okay.